RAG comes up in almost every GenAI developer interview, so let's go deep on it, one question at a time. Everything you need to know about Retrieval Augmented Generation in the next 5 minutes. Question 1. What is RAG, and why use it? RAG stands for Retrieval Augmented Generation. Instead of relying only on what a model memorized during training, RAG retrieves relevant documents at query time, then generates an answer grounded in that retrieved content. Without RAG, a model can only answer from its training data, which is often outdated or simply wrong for your specific use case. With RAG, answers are grounded in your own current data, and you can update that data without retraining the model at all. This is exactly why companies use RAG instead of constantly fine-tuning a model every time their internal documents change. It's far cheaper and faster to update a document store than to retrain a large language model. Question 2. How does chunking strategy affect RAG quality? Before documents can be searched, they're split into smaller chunks. If chunks are too small, you lose surrounding context. The model can't tell what a sentence is really about. If chunks are too large, you dilute relevance, irrelevant text gets pulled in alongside the useful part. Most production systems use overlapping chunks, typically 10 to 20% overlap between consecutive chunks, which gives the best balance between preserving context and keeping retrieval precise. Question 3. How do you choose an embedding model? It depends on your content. For general short queries and everyday text, general-purpose embedding models work well. For specialized domains like legal or medical documents, a fine-tuned or domain-specific embedding model captures terminology much better. And if you're working with multiple languages, you'll want a multilingual embedding model built for that. The key trade-off to mention in an interview is embedding dimension size versus retrieval speed. Larger embeddings capture more nuance, but cost more to search at scale. Question 4. Which vector database should you use? It depends on scale and infrastructure. Pinecone or VBA for managed, production scale needs where you don't want to run your own infrastructure. FAISS for local, lightweight prototyping when you're still testing an idea. Or pgvector if you want to stay inside an existing PostgreSQL setup instead of adding an entirely new system to your stack. Question 5. What's the difference between traditional RAG and Agentic RAG? Traditional RAG retrieves once, then generates an answer, a simple, linear process. Agentic RAG adds a decision-making loop. The agent evaluates whether the retrieved information is actually good enough, and if not, it can retry the search, rephrase the query, or even call a different tool entirely. This is what allows Agentic RAG to handle complex, multi-hop questions that traditional RAG typically struggles with. A good interview example is a question that needs information from 2 different documents to answer fully. Traditional RAG often misses the second retrieval entirely, while an agentic system recognizes the gap and goes back for more. Question 6. Why add a reranking step? Vector search is fast, but it's approximate. It ranks results by similarity, not necessarily true relevance. A re-ranker model takes the top candidates from vector search, say the top 20, and rescores them much more precisely, narrowing it down to the best 3 to 5 before they're sent to the LLM. You get meaningfully better answer quality, without slowing down your initial retrieval step. Question 7. How do you evaluate whether a RAG system is actually working well? 2 metrics matter most. Retrieval precision. Are the chunks you're pulling back actually relevant to the question? And generation faithfulness. Does the final answer stick to what was retrieved, or does the model hallucinate beyond the source material? A system can be weak on either metric and still sound confident, which is exactly why both need to be measured, not just assumed. That's everything you need to know about RAG for your next interview. If this helped, subscribe. Next up, we're covering LangGraph, MCP, and deeper agentic AI topics. See you in the next one.